Hello everyone, welcome back to another segment of the lecture. So in this segment we are going to talk about logical arguments. So what we are doing so far, we are talking about statement, mathematical statement or proposition. And we saw different type of mathematical statement. A mathematical statement is a English sentence that can be evaluated to either true or false. All right. Now what is the purpose of learning different kind of statement? Okay, so we saw about some simple statement, or a statement can be compound statement using different type of operator. Now the purpose of knowing about the statement is that we want to know about argument. So given some statement, given some set of statement, if the set of statement is true, can we prove them some other statements are true? So an argument is a finite collection of statements like a1 to an. They are known as hypotheses or premises, followed by a statement b called the conclusion. So this is an argument. I am saying a given statement as a hypothesis. I am introducing some statements as a hypothesis. Then I am following another statement as a conclusion. Okay. Now a argument is valid if the premises are all true, then the conclusion is also true. All right. A valid argument has a form like this. So set of argument, these arguments are hypotheses or premises. They are hypotheses, all right, or premises, and given these hypotheses are all true, whether the conclusion is true, a valid argument will have a form like this. If all the hypotheses are true, then b is also true. Okay, let's see just one example. Okay, so let's try to find out whether the following argument is valid or not. All right, so here we have a set of hypotheses here. We have p implies not q, r implies q, and r. Okay, so given the hypothesis, we have to find out whether the conclusion not p is true or not. All right, so a valid argument has this form. Okay, we have to find out whether this argument is valid or not. How we can find out? The simple way to find out is using a truth table. Okay, so the simple way to find out whether a argument is valid or not, just simply use a truth table. So we have here statement, all statement we have here, elementary statement we have here, p, q, and r. So we're going to create a truth table using p, q, and r. Okay, so what are all our hypotheses? We have three hypotheses here. A1 is p implies not q. So try to find out p implies not q. So we have p, q, r, all the combination of p, q, r, the truth table. So we're going to find out p implies not q. So that's why we first created the not q, truth table for not q. Okay, then we have another hypothesis, r implies q. Another hypothesis, r implies q. Okay, and we'll determine the truth table for that. So another r is another hypothesis. We have already truth table for that, and we have to find out whether not p is true or not when all the arguments are true. So let's find out in which case all the arguments, all the hypotheses are true here. Okay, so let's find out in which case all the hypotheses are true. So here if we look at the hypothesis, this is our hypothesis, a1, a2, and this is our hypothesis a3. Okay, we can see that this is the only case where we can find out all our hypotheses are true. Okay, And you can look at all the other row. All the hypotheses are not true in any row. Okay, some of them are at least false. So true, true, false, false, true, true, false, true, 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 false, false, true, true. So this is the only row where, this is the only case, all right, where we can find all the hypotheses are true. Now for this row we have to find out whether the conclusion B, so this is our conclusion B, whether this conclusion is true or not. Okay, so in this case we have all our hypothesis is true, and we can see that our conclusion is also true. Okay, we have all our hypothesis is true, and we find out our conclusion B is also true. So that means our argument here is valid. So here our argument here is valid, because given that all the hypotheses are true, okay, our argument, our conclusion is also true. So an argument is valid. So whenever we will find a case when all the hypotheses are true, the conclusion B has to be also true. Okay. All right. So let's see another example. And in this example, we are going to see an example using like real English statement. Okay, English sentence. All right. We have to determine whether the following argument is valid or not. Let's see, if I like biology, then I will study it. Either I study biology or I fail the course. These two are the hypotheses. Okay, these two are the hypotheses. If I like biology, then I will study it. Now either I study biology or I fail the course. These two are my hypotheses. Okay, now I have to find out if these two hypotheses are true. Then if I fail the course, then I do not like biology. If I fail the course, I do not like biology. This is my conclusion. All right, so I have to assume that when these two hypotheses are true, that means these two cases will be true, the conclusion has to be also true. If I fail the course, then I do not like biology. Does that mean anything? Okay, someone is telling you that, okay, if I like biology, I will study it. Either I study biology or I fail the course. Okay, you know, these are hypotheses. Now someone is telling you, if I fail the course, that means I do not like biology. Now just looking at the statement, if you have to you may think that does that make sense? Okay, is it a real argument? Is it a valid argument? Okay, now the thing is that now you know the way how you can prove whether this argument is valid or not. Okay, so let's find out how we can prove that whether this argument is valid or not. Okay, so what type of elementary statement we have? So if I like biology, let's see, I like biology, make it P. Okay, I study biology, make it Q. All right, I fail the course, make it R. Okay, so if I like biology, then I will study it. So that means if I like biology, okay, if I like biology, then I will study it. That means P implies Q. This statement is equivalent to P implies Q. If I like biology, I will study it. Okay, so I study biology or I fail the course. Either I study biology, which is Q, or I fail the course, which is R. Okay, so which is equivalent to Q or R. Okay, so that is our two hypotheses. That is our two hypotheses. Given these two hypotheses, I have to find out whether a argument is valid or not, which is the conclusion. So we have to find out whether this conclusion is true or not. So when the hypothesis is true, our conclusion has to be also true. In every case, our hypothesis is true, our conclusion has to be also true. if I fail the course means R, then I do not like biology, which is not P. Okay, if I fail the course, then I do not like biology. That means R implies not P. Okay, R implies not P. Now let's try to find out whether this one is valid or not valid. So the simple way is that we are going to create a truth table. Okay, we are going to create a truth table. We have these three elementary statement P, Q and R, and these are all the hypotheses. This one is, let's see, A1, A2. Okay, and this is our conclusion B. All right, so I want to ask you to work with that truth table and try to find out all the cases where all of our arguments are true. We're going to find out where all our arguments, all our hypothesis A1 and A2 is true. So whenever you will find out your hypothesis A1 and A2 is true, then look at the conclusion, that whether your conclusion is also true. Okay, if you find out for every case where hypothesis is true, all right, and conclusion is also true, that means your argument is valid. But if you find any case where your hypothesis is true but conclusion is not true, then that means the argument that you are saying, okay, the argument you are saying, it's not a valid argument. Okay, so I want to ask you spend like around 5 to 6 minutes and draw the truth table and try to find a conclusion, and I will talk about the solution in the next segment.